Hello geometry students, and welcome back to another video lesson today where we continue to talk about quadrilaterals. We're going to spend a little bit more time specifically looking at the certain criteria or evidence that is needed to name quadrilaterals very specifically. So one of the most important things you need to remember is that whenever you look at a quadrilateral, you need evidence. Evidence, right? Down here in red. We need to name all quadrilaterals based upon the markings that we see in the quadrilateral. Markings and evidence that could include congruency marks, both for sides and angles, parallel marks, distance measurements or angle measures, or words. We need to have evidence. We can't say something looks like this just because it looks like it. We're not going to name it because of its looks. We have to have that evidence or these markings. And that's the key piece behind all of this as we continue to look at the different types of quadrilaterals. And so I'm going to go through some of these slides rather quickly, but what I would encourage you to do is to pause them, write down the definition of what makes each quadrilateral unique, what makes it a quadrilateral, and why we name it that way. The first one we're going to talk about is a parallelogram. Parallelogram. Keyword being parallel. So we can say that a quadrilateral is a parallelogram if and only if both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. So typically, we look at parallelograms like this parallelogram ABCD because AB is parallel to DC, that's why they have one triangle, and AD is parallel to BC for those two triangles. Okay, so that's that evidence. A couple other things and different ways to draw it, as you can see down here, right? Even though this one may look like a square, we don't have the evidence. The only evidence we have is that the top and the bottom are parallel and the left and the right are parallel. Same thing in all of these. So the main thing we're looking for in parallelograms are both pairs of opposite sides parallel. Parallelogram. Next, we have what's called a rhombus. A rhombus. This is a quadrilateral if and only if it has four congruent sides. Four congruent sides. So this is that congruency mark, that little tick mark, if you will. In this diagram, right, it shows that EF is congruent to HG, which is also congruent to GF, which is also congruent to EF. All four of those are the same size. Therefore, all four sides are congruent. We call it a rhombus. Even in these two pictures, even though it may look like us, that the left and the right or the top and the bottom aren't the same, based upon the evidence and the markings, we can definitely see that all four sides are congruent because of those marks. Okay, it's that evidence. Now let's talk about the rectangle. Okay, a rectangle. A quadrilateral is a rectangle if and only if it has four right angles. We can call something a rectangle if and only if it has four right angles. Okay, so here's what the traditional picture of a rectangle might look like. Four rectangles. Same thing down here. Even though it looks like a square, it's technically a rectangle. Four right angles. If a quadrilateral has four right angles, 4 times 90, that means the whole quadrilateral would have 360 degrees, meaning all four would have to be congruent, which is what you see in this middle shape and the end shape, that all four angle measures are congruent. And if they're congruent, that would mean all of them would have to be 90. So even though they don't look like they're 90, the evidence here showing that all four are congruent does imply that all four are 90. So technically speaking, by the evidence, we'd have to call these two rectangles. Now let's talk about a square, right, which is a special type of rectangle, believe it or not. We can call a quadrilateral a square if and only if it has four congruent sides and it has 4 right angles. So now we need both 4 congruent sides and 4 right angles, which is what you will see in this diagram up here. I've got 4 right angles. I've got 4 tick marks that show all 4 sides are definitely congruent or the same. Okay, so that's what makes it a square. Very unique. Square is technically a cross between a rhombus and a rectangle because of those properties. And again, even though these don't look like they're squares, based upon the evidence, 4 congruent angles inside a quadrilateral means they're all 90, and all 4 sides have the same mark. Therefore, those are all squares. Then we travel to a kite, not a diamond, but a kite. A quadrilateral is a kite if and only if it has 2 distinct pairs of consecutive sides of the same length. Consecutive sides means adjacent, sides that are next to each other. All right? And we need 2 sets of those, 2 distinct pairs of adjacent sides of the same length. So CD and AD, those are congruent. Then I have another set, AB to C to BC, those are congruent, right? So 1 set and 2 set of sides are congruent, and they are next to each other. They're not opposite. And that's what all of these pictures down here are showing, right? AB is congruent to BC. That's 1 set. AD is congruent to CD. That's a 2nd set. They've got to be distinct. They can't be congruent all to each other, things of that nature. Then we hop on to what's called the trapezoid. A quadrilateral is a trapezoid if and only if it has at least 1 pair of parallel sides. At least 1 pair. Could have more, but we're only looking for 1 pair, which is typically what you see in this diagram up here. HE is parallel to GF. I know it's parallel because of the marking. Right, same thing here in this middle one. AD is parallel to B. Oh, I don't have a letter here. Let's just say that that's BC. All right, or even over here, AB parallel to CD. As long as they have 1 set of parallel sides, we call it a trapezoid. But we need that evidence. The last one then is an offshoot of the trapezoid, and it's more specifically called an isosceles trapezoid. And we call it an isosceles trapezoid if and only if it has a pair of base angles that are equal in measure. Base angles are congruent, because we just learned about what this meant in isosceles triangles. Okay, so if you look at this shape up here, D and C are base angles and they're congruent. And we have AB could be base angles and they're congruent. As long as it's got 1 pair of base angles congruent, we're going to learn that those opposite sides are also congruent, meaning the top and the bottom are also parallel. We're going to get through a lot of that where we have to prove it and show why it's true. But isosceles trapezoid means base angles, all right, are also okay, it's a trapezoid, meaning this and this have to be parallel, right? This and this would have to be parallel, but if I know that there's base angles that are congruent, it's an isosceles trapezoid. So I hope you paused the video at different parts to write down those different definitions. Today you're going to practice on trying to identify what some of these different quadrilaterals are based upon solely the markings. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.